This chapter begins calculations that can be difficult and slightly tedious, so we'll do this chapter in two parts. This problem involved estimating time, that is, people were asked to estimate how much time had elapsed. And the first thing we notice, we have our data, but that we have a total of 8 elements of data. The mean, which I call bar x, is calculated by adding all the data elements together and then dividing that by the number of elements. In this case, n equals 8. When we do the calculations, we find that bar x is equal to 58.25, which we round up to 58.3. In order to calculate the median, we must arrange the data in ascending order, and then we find the number that's in the middle of the data. In this case, because we have an even number of elements, we take the two numbers in the middle, divide them by 2, and then find our calculation. In this case is 55.5. And we say that the median is called tilde x. The mode is the number that occurs most often. In this case, it's the number 49. The min range is found by taking the lowest number, adding it to the highest number, and dividing by 2, which gives us the middle of the data. In all of the cases, we're trying to find the extremes in the middle of the data. The standard deviation is an indication of how much the data varies from the mean. And so we have this formula to calculate, but first we begin with some of the data from the previous problem. The information we needed from the previous calculations are the number of elements n, which equals 8, and the mean bar x, which is 58.25, which we rounded up to 58.3. The formula says we're going to take all the elements, subtract bar x, and square them, then divide by the number of elements minus 1, and take the square root. So when we do the calculations involving the elements minus bar x, we find a sum of 627.52. Then we divide by 8 minus 1 and take the square root. Then we come up with 9.47 seconds. This is the standard deviation. Some further calculations involve the variance, which is standard deviation squared, and it gives us the number 89.6 in seconds squared. At first, this doesn't make sense, but simply we're going to use the variance in later calculations. One final calculation is the range. Again, it's simply take the highest element, subtract the lowest one, and that gives us 26 seconds. There must be an easy way of calculating standard deviation, and sure enough, this is called the range rule of thumb, and it gives us a very rough calculation of standard deviation. In this example, we're looking at the ages of different people. In this case, 10. So we have n equals 10 because there are 10 elements, 10 people of different ages. We arrange the ages in ascending order and then find the range by taking the highest age minus the lowest age. In this case, the range is equal to 13. Now we find the standard deviation, and it's simply the range divided by 4. In this case, 13 divided by 4. So the standard deviation is 3.25 years, a lot easier than the previous calculations. We find the mean bar x by taking the sum of all the ages and dividing by 10. In other words, all the ages divided by the elements, and we find it to be 25 years. Now we can also find more information about the data. For example, what is the maximum? Is take bar x and add the standard deviation, and we find it to be 28.5 years. Likewise, we find the minimum by saying take bar x, 25 minus standard deviation, 3.25, and the minimum is 21.75 years.